Hi learners! In today's video, you will learn the meaning of each term in the formula for determining the partition point that divides a directed line segment into two parts with a given ratio. We will break the formulas down into parts and relate each part to visual representations so that you will be able to understand what each term in the formula represents. Talking of visual representation, a previous video on determining the partition point that divides the directed line segment into two parts with a given ratio using a graphical representation is out there. The video is entitled Partitioning Directed Line Segment on the Coordinate Plane without using a formula. Watching the video first will greatly help you understand the basic principles in partitioning the directed line segment. The link is down below. Strategies in analyzing and solving problems related to the topic are showcased to let you gain an understanding on how these are done so that you'll be able to successfully answer geometry problems similar to these in the future. If your lesson is on partitioning directed line segment on the coordinate plane, or if you have an assignment on this topic, or if you're preparing for a test in math, or a test in geometry in particular, or you are someone who is interested in learning math, then this video is for you. On the previous video, we described a line segment as a part of a line bounded by two endpoints and contains every point on the line that is between its endpoints. On the diagram is line segment MH. These can also be named as line segment HM. Such is possible for a line segment just describes a length. If the length is 5 units, you can start measuring from M or H. You will get the same thing. On the other hand, directed line segment MH has length and direction. Because it has direction, it has a starting point, the initial point, and a terminal point. The convention is that the first letter of the segment's name represents the initial point if there is no mention of where the line segment is directed. For the directed line segment MH shown on the diagram, point M is the initial point and point H is the terminal point. Because line segment MH has direction, it is different from directed line segment HM. For the latter has H as its initial point and M as its terminal point. The convention is to name the X and Y coordinates of the initial point as X1, Y1 and the terminal point as X2, Y2. Thus, line segment MH will have these for its coordinates. Now that we know what a directed line segment is, let us go into partitioning a line segment. The word partition means divide into a certain ratio. To do this, we have to look for a partition point that will exactly divide the directed line segment with a given ratio on the coordinate plane. There are two types of ratios that we need to be familiar with here: the partition ratio and the part-to-whole ratio. Let us look at this diagram, learners. Let us assume that point H partitions the directed line segment MN into MH to HN with a ratio 2:1. From the statement and the diagram, we get the following information. First, the directed line segment MN has H as its partition point, M as its initial point, and N as its terminal point. Second, the ratio 2:1 is a partition ratio or part-to-part ratio. This indicates that segment MN is divided into 3 equal parts where MH has 2 parts and HN has 1 part. Learners, you have to pay attention to this important information. From the partition ratio or part-to-part ratio, we can quickly convert it to part-to-whole ratio. Knowing how this is done is very important, for the partition ratio is oftentimes the ratio that is given in the problem, but the formula requires a part-to-whole ratio. As mentioned earlier, the partition ratio of 2 to 1 informs us that the whole segment is divided into 3 equal parts. Thus, the part-to-whole ratio of MH to MN is 2 to 3. It means that MH has 2 equal parts and MN is divided into 3 equal parts. Did you get it, learners? This part-to-whole ratio of 2 to 3 further indicates that MH is 2/3 of MN. In the formula, we write the ratio in fraction form. Okay, let us have the formula for finding the x and the y coordinates of the partition point and examine the other terms that are on it. For the x coordinate, we have x1 plus change in x times part-to-whole ratio. For the y coordinate, we have y1 plus change in y times part-to-whole ratio, where x1, y1 are the coordinates of the initial point, x2, y2 are the coordinates of the terminal point. Change in x is x2 minus x1. Change in y is y2 minus y1. And part-to-whole ratio, the ratio we just discussed earlier. Let us consider x1 and y1 in the formula and relate this to the diagram of directed line segment MN that we have here. On the diagram, M is the initial point. Being an initial point, its coordinates are named x1, y1. Do you agree? Thus, point M with coordinates -5, -3 has x1 equal to -5 and y1 equal to -3. So in the formula, x1, y1 will be replaced with the coordinates of the initial point. Can you follow, learners? Thus, identifying the initial point correctly on the directed line segment is important. Remember that the first letter of the directed line segment's name represents the initial point if no direction is indicated. Next, we examine these terms, change in x and change in y. Look at the diagram again, learners. We will first draw the run and the rise on directed line segment MN like this. Note that the run is the horizontal component of the length of the segment, while the rise is the vertical component of the length of the segment. The change in x that is in the formula is the length of the run. Likewise, the change in y that is in the formula is the length of the rise. Now, how do we get the change in x and the change in y? To get the change in x and the change in y, we will need both the initial point and the terminal point of the directed line segment. Take note that M, being the initial point, has the coordinates x1, y1, while the terminal point has the coordinates x2, y2. To get the change in x, we have to subtract x1, the x coordinate of the initial point, from x2, the x coordinate of the terminal point. Thus, change in x is equal to x2 minus x1. In like manner, to get the change in y, we have to subtract y1, the y coordinate of the initial point, from y2, the y coordinate of the terminal point. Thus, change in y is equal to y2 minus y1. So far, we have discussed all the terms that are on the formulas. Now, let us look at the formulas and the diagram again and try to have a clear visualization of how these two are related. It must be clear to everyone that when you're looking for a partition point of a directed line segment, you are looking for the x and y coordinates of the point that is between the initial and the terminal point. These are what the formulas are all about. Now, when you are looking for that point, where do you start with your search? You do it immediately after the initial point. Thus, the first terms in the formulas are the coordinates of the initial points, which are x1 and y1. Your search is directed towards the terminal point, away from the initial point. Thus, you are adding something to x1 and y1. This is why you have the plus signs in the formulas. Now, how far are you going to move away from the initial point? x1, y1 in search of the partition point? That depends on how much the part-to-whole ratio of the change in x and the change in y are. Hence, this part of the formula, change in x times part-to-whole ratio and change in y times part-to-whole ratio. Okay, so since we have covered discussing all the terms in the formulas, let us have this sample problem so you will know how easy it is to get the answer using the formulas. Okay, so we have sample problem 1. Here's the problem. On a coordinate plane, the endpoints of directed line segment MN are M, -5, -3, and N, 4, 9. Point H lies on the line segment MN and divides it into 2 such that the ratio of MH to HN is 2 to 1. What are the coordinates of point H? Option A, -2, 1. Option B, 1, -2. Option C, 5, 1. Option D, 1, 5. As usual, we begin by reading the whole problem and may read it several times when needed to know what we're looking for, to determine what are given, and to figure out how the given information help find what we're looking for. What are asked in the problem, learners? We're asked to find the coordinates of point H that would divide MN into 2 segments such that the ratio of MH to HN is 2 to 1. What are given? We're given the endpoints of the directed line segment MN, which are M, -5, -3, and N, 4, 9. The problem also states that point H lies on segment MN and is dividing the segment into 2 such that the ratio of MH to HN is 2 to 1. Okay, so let us have the formulas again. Look at the formula, learners. We need x1 and y1, the coordinates of the initial point. How do we know which one is the initial point again? You are correct. The initial point is the first letter of the segment's name, thus point M is the initial point. With that, x1 is -5 and y1 is -3. Next, we need the change in x and the change in y. To get these values, we need both the initial point and the terminal point of the directed line segment. The initial point is M, -5, -3, and the terminal point is N, 4, 9. Let us get these values. For the change in x, we have x2 minus x1. Plugging in the values, we have 4 minus a -5. 4 minus -5 is 4 plus 5, giving us 9. Thus, the change in x is 9. For the change in y, we have y2 minus y1. Plugging in the values gives 9 minus a -3. Now, 9 minus a -3 is 9 plus 3, and this gives us 12. Hence, the change in y is 12. We're done with the first and the second terms on our formulas. Next, we get the part-to-whole ratio. What is given in the problem is a partition ratio or part-to-part ratio of MH to HN, which is 2 to 1. From this ratio, we understand that the whole segment is divided into 3 parts. That is, 2 parts plus 1 part is 3 parts. Thus, the part-to-whole ratio of MH to MN is 2 to 3, or 2/3. This means that MH is 2/3 of MN. Did you get it, learners? We now plug in the values we obtained earlier into the formulas. We start with the x-coordinate. x1 being -5, change in x is 9, and 2/3 for the part-to-whole ratio. Multiplying 9 and 2 gives us 18. Dividing 18 by 3 gives us 6. Now adding -5 and 6 gives us 1. Thus the x-coordinate is 1. Okay, so we now get the y coordinate. Thus, we plug in the values. -3 for y1, 12 for the change in y, and 2/3 for the part-to-whole ratio. Multiplying 12 and 2 gives 24. Dividing 24 by 3 gives us 8. Adding -3 and 8 gives 5. The y coordinate is therefore 5. Hence, the coordinate of the partition point H are 1, 5. Wow, that was easy. So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. Take note that a graph of the directed line segment was not given here. We did not also attempt to graph the directed line segment. Yet, we were able to find the partition point by simply using the formulas. If a graph is given, that means that you have more than enough information at hand in order to find the partition point. With the formulas as your guide, you will know what information to process. Okay, so let us have one more problem so you will get the hang of it. Here is sample problem 2. On a coordinate plane, the endpoints of line segment OP are O, -5, 2, and P, 7, 6. Point R lies on line segment OP and divides it into two line segments such that the ratio of OP to RP is 4:1. What are the coordinates of point R? Option A, -5, 4. Option B, -2, 3. Option C, 1, 4. Option D, 4, 5. As usual, we begin by reading the whole problem and may read it several times when needed to know what we are looking for, to determine what are given, and to figure out how the given information help find what we are looking for. What are asked in the problem, learners? We're asked to find the coordinates of point R that would divide OP into two segments such that the ratio of OP to RP is 4:1. What are given? We're given the endpoints of the directed line segment OP, which are O, -5, 2, and P, 7, 6. The problem also states that point R lies on line segment OP and divides it into two line segments such that the ratio of OP to RP is 4:1. Okay, so let us have the formulas again so we will be guided on what information to process. Okay, so the formula calls for x1 and y1. Remember that these are the coordinates of the initial point. Which one is the initial point again, learners? You are correct. The initial point is the first letter of the segment's name. Hence, it is point O. Thus, x1 is -5 and y1 is 2. Next, we get the change in x. Here, the initial point and the terminal point are needed. Plugging in the values into the change in x, we have x2 minus x1, 7 minus a -5. 7 minus a -5 gives us 12. So the change in x is 12. Plugging in the values for the change in y, where you have y2 minus y1, we have 6 minus 2. 6 minus is equal to 4. So the change in y is 4. Next, we get a part-to-whole ratio. Take note that what is given is a ratio of OP to RP, which is 4:1. What is the name of the segment again? You are correct. It is segment OP. Thus, OP is divided into 4 parts. Do you agree? Now, the whole segment is partitioned by R, where RP is 1 part. From here, we can see that OR is composed of 3 parts. Can you follow, learners? Thus, the part-to-whole ratio of OR to OP is 3:4, or 3/4. This means that OR is 3/4 of OP. We now plug in the values into our formulas. Starting with the x coordinate, we have -5 for the value of x1, 12 for the change in x, and 3/4 for the part-to-whole ratio. Multiplying 12 and 3 gives 36. Dividing 36 by 4 gives 9. Adding negative 5 and 9 gives 4. Thus, the x-coordinate is 4. Now, for the y-coordinate, we have 2 for y1. The change in y is 4. And the part-to-whole ratio is 3 over 4. Multiplying 4 and 3 gives 12. Dividing 12 by 4 gives 3. Adding 2 and 3 gives us 5. Thus, the y-coordinate is 5. Therefore, point R has the coordinates 4, 5. That was easy, right? So, what is our answer, learners? Is it option A, option B, option C, or option D? Okay, so the answer is option D. Learners, you must have noticed that our work is faster, shorter, and with accuracy. There you are, learners. Hope you acquired lots of learnings in today's video. Let us summarize what we have learned today. We have learned that, first, a directed line segment is a segment having length and direction. Second, partition ratio is a ratio comparing a part of the whole to a part of the whole segment. Third, the sum of the partition ratio gives the total number of parts that the whole segment is divided into. Fourth, the part-to-whole ratio compares a part of the segment to the whole segment. Fifth, the formulas for getting the x and y coordinates of the partition point of a directed line segment are: x coordinate is equal to x1 plus the change in x times part-to-whole ratio. Y coordinate is equal to y1 plus change in y times part-to-whole ratio, where x1, y1 are the coordinates of the initial point, x2, y2 are the coordinates of the terminal point. Change in x is x2 minus x1, and change in y, y2 minus y1. And lastly, part-to-whole ratio, comparing the part of the segment to the whole segment. Sixth, when solving a problem, you must read it and may read it several times when needed to know what you're looking for, to determine what are given, and to figure out how the given information help find what you are looking for. There you are, learners. Hope this video helps. That's it for now. If you have any question, leave a comment below, and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.